Welcome. My name is Ron Papa Schmidt, and I'm the creator of the Net Zero Now YouTube channel. And this video is going to be part of the science playlist, and it's going to talk about extreme weather. Now, we're going to ask this question: how does climate change impact extreme weather? And we're going to limit the discussion to thunderstorms, tornadoes, and tropical cyclones, or hurricanes, as we call them in the United States. I'm going to do that just because of time constraints. Now, if you take a look at the pictures on the right-hand side of the screen, you'll see some damage that has occurred from some tornadoes and thunderstorms in the United States this year. You know, this year we have just been hammered by thunderstorms and tornadoes. And in this example here, I just took two. Like on April 7th, there were 20 people that died from severe weather in the Midwest and the southern United States, okay? And then on May 22nd of this year, there were 724 tornadoes in one day in the United States, and approximately 35 people died. Now, when you look at floods, which are the impacts of some of these heavy thunderstorms, etc., everybody can remember the Texas floods, where tragically 135 people died. And I showed on the bottom one other flood. This occurred in Milwaukee August 9th and 10th. Now, the reason I showed that is I originally grew up in Milwaukee and very familiar with the area. And they had this massive thunderstorm and related flooding, which caused significant damage. Now, that stuff just wasn't happening, 10, 15 years ago. So the question is, what's causing that? Is it really climate change that's impacting that? And that's what we're going to try to address in this session today, okay? So really we're going to do that by really talking about two questions we're going to explore. First one is, what causes thunderstorms, tornadoes, and tropical cyclones, or hurricanes, as we call them in the United States? So first of all, how do they... what causes them to occur? Okay, so we're going to discuss that first. That's most of the scientific aspect of it. And then the second question we're going to explore is, do higher temperatures impact tornadoes and thunderstorms and tropical cyclones? But before we do that, I guess we need to sort of test validity of assumption, with regard to surface temperatures. Have actual surface temperatures been increasing? And the answer to that just simply is yes. During the last 10 years, as you can see from this graph, and we discussed that in this graph in detail in other presentations within the Net Zero Now YouTube channel. But during the last 10 years, global temperatures have increased by 0.5 degrees Celsius, basically from 1 to 1.5 degrees Celsius, if you looked at the pre-industrial level, and by 0.9 degrees Fahrenheit. Now that gets us to sort of the next question: well, will these temperatures continue to increase? And the answer to that is also an emphatic yes. And we've got a table below that shows how temperatures are going to increase in the future, and with some really significant consequences to us. Now, I covered that in great detail in session 2, the why, of part of the foundational core playlist. If you haven't already looked at that, after this, that you really should go back and look at that. It really will help you understand this issue. But I'm not going to cover that now in the interest of time. So, what causes tornadoes and hurricanes? Well, it's a simple answer. It's thunderstorms. Okay. So what causes thunderstorms? Clouds. What causes clouds? Okay, so how clouds are formed? It's really pretty simple. First of all, we have water vapor. Primarily enters the atmosphere through evaporation. And when it does that, it's really a gas, okay? And as it rises, it cools. There's also some that comes through transpiration, but we're going to talk about the gas aspect of this. And when you go to, as it's rising, it cools, and when it reaches a dew point, the water vapor is ready to form a cloud. But in order to do that, it needs to find a condensation nuclei that it can attach itself to. And when billions of these condensation nuclei are suspended together, become visible, they become visible as a cloud. So that's how clouds are formed, okay? So I guess that gets you to the next question. Okay, well, where do these condensation nuclei come from? Well, they come from all kinds of things. You know, dust and salt, from soot and black carbon, volcanic ash. You know, that also comes from forest fires and other kinds of things like that. Sulfates from marine organisms, pollens, organic aerosols, and then human-made sources. We do a lot of that too with smoke and industrial processes and exhaust fumes, etc., and things like that. So the other thing, we determined that in order for a cloud to form, it needs to rise. So what causes it to rise? Well, there's four major ways. One is convection. You know, this is where the sun heats the ground and which warms air, and warm air rises. The other is sort of frontal lifting, where warmer air encounters a denser, cooler air mass, which forces it up. Or there's orographic lifting. This is when wind forces hit a physical barrier like a mountain range. Or convection, when a wind is coming in different direction and pushing basically the wind higher. So that's how that's the lift factor that's required to form a cloud. Also, so what are the major types of clouds? There's a bunch of them here. There's really two that are important for this discussion. And the first one is the cumulonimbulous cloud. That's this, if you look at this chart, that's the one on the left-hand side that goes from low to very high. So this is a very tall, if you want to say that, cloud. And because it goes so tall, it is really the source of where our tornadoes come from. A lot of our thunderstorms come from. Intense rain, storms, hail, etc., come from those kinds of clouds. And then the other ones we have are the nimbostratus clouds, and those clouds don't go as high in the atmosphere, but they do produce significant continuous rainstorms and snowstorms over wide areas. So those are the kinds of clouds that are typically involved in that kind of activity. So how are thunderstorms created? Well, thunderstorms are created by sort of a rapid upward movement of warm, moist air within an unstable atmosphere that leads to the formation of these sort of towering cumulonimbulous clouds, okay? And what are the three key ingredients that are necessary? One, you've got to have moisture, so warm, moist air to feed the cloud. You got to have an unstable air, the warm, moist air near the ground, and you have to have cooler, drier air up above, which allows the moist air to rise just rapidly, as you can see in this diagram over there. And then the other thing you need is a trigger, something to push the air upward. And we covered that in point 3. So during this development stage, we have massive amounts of warm air coming up, and the cloud and because of the warm air and the amount of moisture, the cloud just gets taller and taller and taller. And then it starts, and so what happens, and we go to then the mature stage. And at this stage, as the cloud grows very tall, water droplets form and they get heavier. Actually, some of them turn to ice as they get to the very high parts of that. They start falling. And as they fall down, they drag cool air downward, creating a downdraft. But simultaneously, you also have this warm upward draft going on also. And so it is that pressure of those conflicting up and down flows that cause lightning, the friction that causes lightning and the interactions. It also causes hail and this heavy rainstorm. And sometimes for hail, what happens is it goes as it's coming down, the warm, as it's heavy and it's coming down, the warm, it starts melting. But what happens is the upward pressure is so high, it pushes it back up into the upper layers of the cloud. And then it comes down, only this time it's slightly heavier because it didn't melt completely when it went up. And sometimes if they complete this cycle often enough, you can end up with baseball-sized hail. But that's what really causes the hail. Eventually, it just becomes so heavy that it's stronger than the downdraft, and the hail just comes down. Okay, and then you have the final stage, which is the dissipating stage. And here you can see. At this point, the upward draft has sort of been overcome by the downward draft, and so the storm supply of warm, moist air decreases, and it just sort of dissipates or gets rid of the remaining precipitation in the cloud. Okay, so that goes to the next question. So how are tornadoes caused? Well, tornadoes are really occur within thunderstorms in these cumulus clouds. And so if you take a look at this sort of the big picture here on the left-hand side, if you look at the bottom of, you see a shelf cloud, stations, stration, and shelf cloud. And you see the precipitation coming down from that. Okay, so that's what rain. So, but what also happens, you have wind going on. If you take a look at the diagrams at the right, we have three. So the first one, what typically happens at the beginning is you get wind shear sort of going on. It's moving, in this case, from left to right. But then there's some updraft, some event that causes it to start having a little bit of updraft. And then eventually it goes to a straight updraft. And when you get the straight updraft, that's when you get a tornado. So if you take a look at the diagram here, you can see the precipitation at the upper right-hand one, where it just shows the precipitation occurring. It's the same thing true as it starts to upend, but when it gets upright, that's when you can start generating a tornado. So tornadoes really come out of these massive thunderstorms when you have other conditions that can cause the upward drafting to occur. Now, how are tropical cyclones or hurricanes created? Well, tropical cyclones are really hurricanes, are created really from a cluster of thunderstorms that's sort of organized into a rotating storm system. And how that occurs is you have sort of moist air that's rising from the ocean as it cools and condenses in the clouds, causing more air to create a cycle of intensifying storms, okay? And then you have the Cryosphere effect, where Earth's rotation causes the winds to spin into a vortex around the low pressure center, therefore creating more speed and intensity and creating a massive hurricane, which really consists of multiple thunderstorms and frequently tornadoes within it. And you can see the diagram below on the lower right of how that works. And on the lower left is an interesting from the International Space Station in 2018. It just shows the eye of a massive hurricane and gives you a sense of its scope and what it looks like. So basically, we have this graph that we started with, and we so far have concentrated in answering the first question of what cause is thunderstorms, tornadoes, and tropical cyclones. So now let's move on to the second question. And the question is, do higher temperatures impact thunderstorms, tornadoes, and tropical cyclones or hurricanes? And the simple answer is yes. That gets to the next question, I guess, is wow. Well, there's really a number of steps here involved, but let's start with the most important one. Here's what happens. At higher temperatures, what they do is they impact the frequency and the intensity of severe weather, okay? They don't cause them, but they cause them to occur more frequently, and they make them bigger or more intense. And reasons for that, well, let's look at point number one. For every degree of Fahrenheit of warming, there's an additional 4% more moisture coming into the atmosphere, which is a major source of these storms, okay? And you can just see from the chart here on the upper right-hand corner that this tracks historically what's happened to changes in atmospheric moisture. And you can see that it's going up just like the temperatures are going up. And that's the primary reason. There's the biggest one. That would be the biggest reason why we have more frequent and more intense thunderstorms. There's more raw material to work with, okay? Now, there's some other important factors here, too. Like number 2 is there's more particulate matter in the atmosphere also. We discussed what those were, and if you look at that chart, that's obviously a thing. Then there's increased atmospheric stability, leading to more updrafts and downdrafts, etc. There's stronger downdrafts because the updrafts are creating clouds that are higher, and therefore when they come down, they have higher wind speeds, etc. There's increased precipitation because the cloud system thunderstorms are larger, and they become more frequent, and more frequently involve hail the taller the thunderstorms become. So all of those reasons above cause more severe thunderstorms, tornadoes, and hurricanes, okay? Well, let's go to another point here. And this I want to talk about personally, okay, because higher temperatures cause the jet stream to meander, resulting in increased size of weather fronts, weather patterns staying in one place longer, and more intense storms. Now, we covered this, if you take a look just below me of this shot of Earth and the jet stream, you can see the blue stream and how it is now meandering more than it used to. Now, we covered this in detail in session 3, where we talked about how Earth's climate systems work. But as a result of that, what it does is it pulls more cold air down from the Arctic, and also pushes more warm air up into the Arctic, which causes that to move faster. As it meanders, the storm moves slower, so that's why storms stay in place more. That's why storms last longer than they have before. And this increased temperature difference, if you look at it, is covering a much wider range. That's why it's another reason why we have much bigger thunderstorms also, okay? And thunderstorms lead to tornadoes, etc. Now, if you take a look at the top here, which is hard to read the map of the world, but the orange areas are really where tornadoes occur. And tornadoes, if you look at it, they're really one of the major areas for tornadoes is the United States. Well, why is that? Well, let's go to the map below here. If you take a look at the map below, let's start with the jet stream in green. And you can see the jet stream is pulling more, like we have on the meandering graph here, chart. It's pouring more cold air down to into the United States, towards the Gulf. You have warm air coming because of increased temperatures. The air is getting warmer in Arizona and in New Mexico and western Texas. And so that warm, dry air is also moving upward. Now, you also have warm, moist air being fed from the Gulf. And it's warmer and moister. Why? Because it's the Gulf, temperatures of water in the Gulf have been going up, so it creates more moisture, and it's hotter moisture. It's more moisture. And so what happens is that also, though, you need something to sort of cause it to lift, and you have the Rocky Mountain range that occurs across down the United States. So we are sort of uniquely set up to have tornadoes. In fact, they have something you see by the sort of pink area there, what they call Tornado Alley. And so that's why higher temperatures are causing us to have more severe storms and thunderstorms, particularly in the United States, and tornadoes, okay? Now let's go to hurricanes. Now, higher temperatures also provide more fuel for hurricanes. Why? Well, the ocean is warmer, right? And air is warmer. And this is an interesting chart. It just is, it covers the year 2024 and all the major hurricanes in 2024. And if you take a look at anyone, let's take Raphael, which is down a way. So if you take a look at it, you see there's a upward downward line occurring just after about half, 2/3 of the way through the Cat 1 category. And you can see it gets to the middle of the Cat 3 category with the arrow. So the length of that arrow is really the impact that climate change or increasing temperatures have had on hurricanes. And so you can just see graphically how they've made hurricanes more intense. Okay? So let's wrap this up. So how does climate change impact our weather? Well, I think we've just gone through it. And we've gone through and demonstrated how, from a scientific perspective, how it's increasing the frequency and tendency and intensity of our thunderstorms, tornadoes, and cyclones. Okay. Now, I wanted to end this with these two pictures here, because we had the flood in the left-hand side in Texas, which I showed you previously, which shows 135 people had died. And when that happened, I think they talked, well, this is once in a 50-year event, a 100-year event, etc. Interestingly, in Milwaukee, when they had their flood, the Milwaukee Journal reported that what the politicians and some people were saying was that, well, this is once in a 1,000-year flood. I mean, bull, that's all I could say, I mean, those are excuses from people who don't want to recognize the reality of climate change. As our temperatures increase, what's going to happen is these storms are going to get more intense. These aren't one in 1,000 years. First of all, 1,000 years? I live in Milwaukee. What did Milwaukee look like 1,000 years ago? There's nobody who can do any scientific research to suggest this is once in a 1,000-year cycle, okay? Or in Texas. I mean, they had prior floods like this, not 50 years ago, and this one's more intense. It's going to increase. There are reasons why these things are occurring. And they're going to get worse every single year if we don't do something about it. And what we need to do about it is to get the net zero greenhouse gases, okay? And so I've devoted this YouTube channel to that. You can see a QR code on the left there that will take you directly to the channel. But if you get there, I would suggest you go to the Start Here video, because the channel is adding more and more videos all the time. It's getting increasingly complex, and that will help you navigate that a little bit more. So, in final thing, I love the Eagles, and they have some great wisdom, and they have a song where they say do something, and there's some lyrics I put here. I just don't have time to read that now. But so what can you do? Well, one thing you can do is you can subscribe to this channel. That way, I'm going to be doing 2 or 3 of these a month. I just started this effort in July. I decided to actually create this channel. And so there's a lot of videos I still need to do to sort of provide the foundational information of what's going on. And if you subscribe, you automatically get that. The other thing it does is it also, when people do inquiries, it influences the algorithm, and maybe more people will get access to this material. Also rate the videos, but more importantly, comment. I appreciate your suggestions for things you think I can do to make this series better, or videos you want me to create. Share the link with friends and family. Folks, I just need to say this. Our politicians and our corporate leaders are not going to solve this problem. They're too tied up in vested interests. And so we're going to have to do it ourselves. And so sharing the link would be helpful, or just talk about the subject, bring it out, and just do something, okay? And so thank you for watching this video. I look forward to having the opportunity to talk to you again.